Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be looking at the topic of effects of electric current on substances, and we are just finishing up on this topic. So today we are going to look at electrolysis of molten compounds, and then we are going also to discuss on some of the applications of electrolysis, and then we will tackle a few questions and end the session. So for electrolysis, it's the process of decomposing an electrolyte by passing an electric current through it. So you see we have an electrolyte. If you pass an electric current through an electrolyte, it decomposes. So that process of decomposing that electrolyte by passing an electric current through it is what we refer to as electrolysis. So we have mentioned an electrolyte in the definition of electrolysis. An electrolyte is a substance which, when melted or dissolved in water, conducts an electric current and gets decomposed by the current. So does not only um, allow current to pass through it, but as a result, it gets decomposed by the current. So it can be melted or dissolved in water. So in Form 4, you are going to discuss on electrolysis of aqueous solutions, but for today, we will focus on the melted one. Solutions of salts, acids, and bases are electrolytes, but now we have a specific type of electrolyte called binary electrolytes. These are the ones that contain only one type of cation and one type of anion. We are going to see another type of electrolyte when we get to Form 4. So this is the setup that we are going to use, and the example of the molten electrolyte we are going to use today is lead-2 bromide. So for lead-2 bromide, it's put in this setup. You can see the anode is attached to the positive terminal of the battery, while the cathode is attached to the negative terminal. So that's the reason why they are called positive and negative. It's not necessarily that they are positive and negative, it's because of the attachment to the cell. And then they are dipped in molten lead, and you can see the lead has been heated, and we know this heat is the one that tells us that it has been heated to molten state. So one of the things that you will notice is that the bulb is going to light. So why does the bulb light? The first thing that also we are going to see is some gases being produced at the anode. How does that happen? So first of all, in the solutions, we have the lead ions and the bromide ions. So we said this is a binary electrolyte. It has only one cation and one anion. So we said all the cations are going to go to the negative electrode, as you can see in the arrow, and then all the anions are going to go to the anode. So when we go to the anode, the negatively charged bromide ions usually attach themselves, and when they reach there, they lose electrons. Bromide ions lose electrons to form bromine atoms. Then the bromine atoms combine to form a diatomic molecule of bromine gas. So on the anode, you're going to see a pale yellow or brown gas. And then bromide ions, as you can see in the equation, are losing electrons. And you can see we are putting the equation on the left, the electrons are on the right side while the reactants are on the left side. So it shows that these electrons are being lost. These electrons travel through the circuit from the anode. They go to the cathode. And then in the cathode, the positively charged lead ions that were attracted to the negative cathode, they usually gain those electrons that have been lost by the anode. When they gain them, they form the lead metal, which is neutral. And you can see the lead-2 plus, it means that it had lost electrons. So if they gain those electrons, they return back to the neutral state. So this is what happens in the equation. Lead ions in aqueous state, they gain 2 electrons to form lead solid. So these are the equations at the anode and the equation at the cathode. If you are told the observations you notice in this setup, first of all, the bulb lights, and then you're going to see a brown gas of bromine, and then also you're going to see some gray bits at the cathode. you're going to see some gray deposits at the cathode. So those are the two observations. So these are other electrolytes. So we are going to derive the cathode equation and the anode equation. And you notice I always start with the anode equation because the anode equation helps you to know how many electrons are being lost. These are the electrons that travel to the cathode to be gained. So when you look at the binary electrolyte, we are going to break it down into its ions. So we have the lead ions and we have the bromide ions. So at the anode, the bromide ions are attached to the anode because they are negatively charged. They migrate to the anode, while the lead ions migrate to the cathode. So the bromide ions are going to lose electrons to form bromine gas. So you see we have one bromide ion losing one electron, but it forms bromine gas. For us to do that, we need to balance the equation. That's the reason why we are losing two electrons and not one electron. And you see you have to balance your equation. So it is two bromide ions that they are losing each one electron to form bromine gas. So these two electrons are the ones that are gained by lead. So the lead ions gain those two electrons lost by bromine to form lead solid. The same thing we do with lead iodide. So we have lead ions and iodine ions in solution. The lead ions migrate to the cathode while the iodide ions go to the anode. On the anode, the iodide ions lose electrons to form iodine gas. And we lose two electrons because it's diatomic in nature. So it means it's two iodide ions that are losing each one electron. So these two electrons migrate to the cathode and the lead ions gain those two electrons to form lead solid. And then another example is sodium chloride. So we have sodium ions and chloride ions. So the sodium ions migrate to the cathode while the chloride ions migrate to the anode. To the anode, the chloride ions lose electrons to form chlorine gas, pale yellow, plus two electrons are lost from each ion. So these two electrons are gained by sodium. And remember, sodium can only gain one electron, so we need two sodium ions to form two sodium atoms. So you can see the difference between this and for the lead. The lead can comfortably gain those two electrons, but sodium only requires one electron, so we need two sodiums. For aluminium oxide, we have aluminium 3 plus and oxygen 2 minus. So the aluminium moves to the cathode while the oxide ion goes to the anode. So on the anode, the oxide ion loses electrons. But now this one is going to be interesting. As you can see from the formula, aluminium oxide, this is the formula of aluminium oxide. You'll notice that for it to be completely balanced, we need two aluminium ions, and each aluminium ion requires 6 electrons from the formula. So, and then three oxide ions, each ion is giving 2 electrons. If there are 3, they'll also lose 6. So we need to lose 6 electrons that are going to be gained by 2 ions of aluminium. So for us to get 6 electrons to form oxygen gas, when we lose 6 electrons, and you can see how I got the 6 electrons is from the formula. So it means we need 3 oxide ions to lose each 2 electrons. If they lose each 2 electrons, they are going to form a total of 6 electrons. These ones can comfortably begin with aluminium because normally we know that oxygen loses 2 electrons and aluminium cannot gain 2 electrons. So we go back to the formula so that we can get how many electrons we require. So aluminium ions will give the 6 electrons, but one aluminium cannot gain 6 electrons, but 2 of them can gain 6 electrons to form aluminium solid, but not just 1, but 2, because each gains 3 electrons. So that's how you do for aluminium. And then magnesium chloride, magnesium ions and chloride ions. So we start with the chloride ions that migrate to the anode. Chloride ions react by losing 2 electrons to form chlorine gas. pale yellow and 2 electrons are lost. So we have to balance the chloride ions. And then now these 2 electrons migrate to the cathode where magnesium ions gain those 2 electrons to form magnesium solid. And I noticed I've not been putting the state symbols. Make sure you put the state symbols well. They need to be there for you to get the full marks. So let's correct that. And finally, the last one, we have the copper ions and the chloride ions in solution. The chloride ions goes to the anode. So the chloride ions once more will lose 2 electrons to form chlorine gas plus 2 electrons. These electrons migrate to the cathode where the copper ions gain those 2 electrons to form copper solid. You can repeat the process slowly again by yourself and see if you can be able to understand. Next, let's look at some of the applications of electrolysis. Electrolysis is used in the extraction of metals, and especially metals that are very reactive like sodium, magnesium, aluminium. So we are going to do them in Form 4 work. And then it's also used in the purification of metals. This is also something you do later. It is used in the electroplating of metals. So we mentioned this in Form 1 when we were discussing how to prevent rusting, although we are going to go to details as well in Form 4. It is used in manufacture of chemicals such as hydrogen gas, chlorine gas, and sodium hydroxide. And then let's do a few questions. The diagram below shows an experiment for investigating electrical conduction in lead 2 fluoride. Study it and answer the questions that follow. So you can see the lead bromide, you can see the bulb. So if you were to identify the electrodes, you can see this is on the smaller part. This is the negative and then this is the positive. So this tells you that this is going to be the anode and this is going to be the cathode. And then on the diagram, label the anode and the cathode. So it's not necessarily for the anode to be placed always on the left side. It can be placed on the right side. Your work is to check the bulb and ensure that you get it. So the positive side of the cell is placed, the anode is the one that is placed that side, while the negative side is the cathode. And the negative is a smaller line, the positive is the larger line. So we have already labeled the anode and the cathode. Show the direction of movement of electrons. So we said the electrons are lost at the anode. So when you are showing the movement, remember to put the arrow on the line. On the line. Don't put on top, on the line. And then complete the diagram by indicating the condition that is missing. So the condition that is missing is heat, because we need the lead 2 fluoride to be molten. Why is it necessary to leave a gap between the cork and the boiling tube? So we are leaving a gap because we are giving off a gas. And that gas that we are giving off is fluorine. So we do not want that fluorine to build up in this solution, because if it builds up, then it's going to react by gaining those electrons again. And then state the observations that are expected at the electrode during the electrical conduction at the experiment. So the observation at the electrodes. So at the cathode, here at the cathode, we are going to notice some gray specks of a lead, and then at the anode, you are going to see a pale yellow gas. Those are the observations. Right? The equation that takes place at the electrodes. So at the anode, we start always with the anode. So the fluoride ions will lose 2 electrons to form fluorine gas. So we balance out, this is aqueous. So, and then at the cathode, those 2 electrons are gained by the lead ions to form lead solid. And then why should this experiment be carried in a fume chamber? Because of the fluorine gas that is going to be produced, which is very poisonous. That brings us to the end I hope you have been able to understand. This is a very short subtopic, and we're going to do the bigger one in Form 4 called electrochemistry. But you can go through it. The most common questions is identifying the anode and writing the equations. Make sure you're able to understand those ones. See you in the next lesson.